Hello everybody. Now that we have gone over the notes and the lessons for the day, let's go ahead and take a look at some application problems. So basically these are going to be similar to what you are going to have to do on your own in your independent practice today. So we're just going to be looking at how to actually set up equilibrium expressions. Again, you guys are not going to be required to solve them. You just need to know how to set them up. Okay? So let's take a look at this example first. So here we've got our just basic stoichiometric equation, right? So we've got 2c, so that 2 is your coefficient, the c would be the compound, and then this is showing you it's an aqueous solution, plus your d, which is again another compound, an aqueous solution, and then this little arrow is a little bit different than what we've seen before, but we're going to be looking at the double arrow today. Then you've got your 3 as a coefficient. A is a compound and aqueous solution. It's aqueous, plus 2b. So the 2 is a coefficient, the b is a compound. And again, this is just general, it's not specific. We're going to look at specific examples in just a minute. And then that 2b is a solid. So if you remember from the lesson that we just did, when we do equilibrium equations, you don't include solids and you don't include liquids. So the first thing you want to do is look at your equation and see if there's any of these compounds that we can go ahead and drop out. And if we look, we've got aqueous, 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 and then we've got a solid. So these three guys are going to be included, but the solid doesn't have to be included because it's constant, so we just leave him out. Also recall that you want to put your concentration of your products over the concentration of your reactants, and your coefficients become your exponents, okay? So remember, reactants on the left, products on the right. So with that in mind, let's go ahead and look at this one. So we have K is equal to, so our compound here is the A, so we're going to have our A in brackets, so the concentration of A, and then 3 is our coefficient, so we're going to put the 3 as the exponent, okay? And we're done, because we don't include the solid. Then the products are going to be over the reactants, so we have C over here, so you're going to put C in brackets to indicate that we would use the concentration of C for this to solve this problem. And then we've got our coefficient as 2, so you're going to put the 2 as the exponent, okay? And then you also need to add your second reactant, which is D, so we're going to put D in the brackets to indicate that we're using the concentration of D, and there is no coefficient for that one, so we don't have to put anything. Technically it's a 1. If you need to put a 1 to help you visualize, it's okay, but you're not going to see it as a 1 on like a standardized test or anything. Okay, and then that's it. That's all you have to do to set up your constant. This is just kind of a plug and chug kind of thing. If you can recognize what goes where and follow the steps, you should get the right answer every single time. Okay, so that's a general setup. Let's look at some actual problems now. So here it says, write the equilibrium expression for the following reaction. So we have our double arrow indicating that this is an equilibrium reaction. So we've got a forward and a reverse. And you've got hydrogen gas, nitrogen gas, giving us 2NH3, which is ammonia gas. So if we have NH3 up here, okay, so remember if we're setting up our equation, we've got a gas, and a gas. So we don't have a solid or a liquid, so that's going to be our indication that all of these are going to be included in our equilibrium expression. So remember, we want to have our products on the top and our reactants on the bottom. So on the top, we're going to have NH3, and then the exponent is going to come from our coefficient. Our coefficient here is 2. So here, our NH3 is going to go on the top, and then we're going to add our 2 as our exponent. So what this would mean is that you would take your concentration of NH3 and you would square it. Okay, so if you had like a concentration, a molarity of like 0.5, you would take that value and you would square it. Again, you guys don't actually have to do the calculations, you just have to know how to set up the expressions. So our product is on the top, so we're done with that. So then we can go to our reactants, which go on the bottom. So we've got hydrogen gas here. So we'll have H2 in our concentration brackets. 3 is our coefficient, so it becomes our exponent. Then we've got nitrogen gas, which we'll add in our brackets. And there is no coefficient, so you don't have an exponent down here. Okay? Again, it's just plug and chug, being able to recognize that the coefficients become the exponents, right? And you need to know that your products are on the top and our reactants are on the bottom. Let's take a look at another one. So here we've got nickel oxide, which is a solid, carbon monoxide to yield nickel and carbon dioxide. So let's take a look. Are there any solids or liquids here? Yes, this is a solid. This compound is a solid. Gas, the gas needs to be included. Nickel is a solid, so this can be eliminated because we don't include solids, pure solids or pure liquids. And then carbon dioxide is a gas. So for this one, we don't even have to worry about the nickel. We're just looking at the carbon monoxide on the left and the carbon dioxide on the right. So again, we're not going to look at either of these compounds. So let's take our carbon dioxide, which is our product. We're going to put him on the top. There is no coefficient, right? So there's no exponent. So we just need to put carbon dioxide in our brackets to indicate the concentration. And then if we go to our left to find our products, we put our carbon monoxide again in brackets to show the concentration. And then there again is no coefficient, so there's no exponent. So to solve for this equilibrium constant, you would just do the concentration of carbon dioxide divided by the concentration of carbon monoxide. Again, we didn't include the nickel compounds because they are solids. You don't include solids or pure liquids when you're calculating these. All right, let's do another one. So we've got nitrous oxide, nitrogen gas, and oxygen gas. So these are all gases. So we're going to include them all because they're not a solid or a liquid. So we're going to put our N2 into brackets, no coefficient, so no exponent, and our oxygen gas into brackets, again, no coefficient, no exponent needed, right? There are your products on the top, done, and then we're going to put them over the nitrogen oxide in the bottom with our exponent of 2. Again, we're grabbing that from the coefficient. So we've got 2 here. So the 2 coefficient that comes in the front now becomes the exponent in our equilibrium equation. Again, these are just plug and chug. If you can follow the steps to do this, you should be able to set them up every time. All right, let's take a look at this one. So we've got 2 molecules of a trioxide gas, and we've got 3 molecules of oxygen gas. They're both gases. So you're going to have your products on the top again. So we're going to put O2, just the compound, in the brackets to show the concentration of O2. You've got a coefficient of 3, so that becomes the exponent for your product. Now our reactant's going to go on the bottom. We've got O3 over here, and then we've got a coefficient of 2. So that becomes an exponent of 2. Okay, so let's take a look at this one. We've got ammonia in aqueous solution, water is a liquid, NH4 plus in aqueous, and a hydroxide anion aqueous as well. So we've got a liquid here, so we don't have to include the water, right? Because water is a liquid, it's a pure liquid, it's a constant, you don't have to include it. So just like before, let's put our products on the top, our reactants on the bottom. So we'll have our NH4 plus in brackets and our hydroxide anion in brackets as well. There are no coefficients for either of those, so there's no exponents needed. And then you've got your NH3 on your left, which is going to go on the bottom because it's your reactant. Is there a coefficient there? No. So do you need an exponent? No. And this is our equilibrium constant equation. Okay, let's do one more. I think one more is probably going to be enough. So here we've got 2 molecules of hydrogen gas. Oxygen gas will yield 2 molecules of water, H2O. H2O is a liquid, so we do not include it in the equilibrium expression. Now, there's only one product here. So if ever that happens where you have a liquid or a solid as the only product and you don't have to include it, just put a 1 on the top, right? We can add a 1 and mathematically it stays the same. And then our reactants, we've got hydrogen gas. So we'll put our H2 in brackets. The coefficient is 2, so it becomes the exponent 2. And then there is no coefficient here, so we just have to put our oxygen gas in exponents, and then you're done. That is the equilibrium expression for this equation. Now, I went through that pretty quick, but mostly because it's just plug and chug, and if you can recognize the pattern, you can set these up every time. Okay, so your independent practice for the day is just going to be practice setting up these equilibrium expressions. You don't have to solve them, but I have included a video for you to watch to show you how to solve them. And then there's a bonus question in your independent practice to actually do the math and solve it, just to challenge yourself and see if you can. So go ahead and get started on that. If you run into any problems or have any questions, let me know. I hope you guys are doing well, and I will talk to you soon.